Welcome back to free engineering tutorial on operating system. So in previous video we had studied about introduction of memory management. Now in this video we will be talking about logical versus physical address space. So as we know that CPU is generating only the logical address and all the contents and resources are stored in main memory or in the memory we can say that. So there it is stored in the form of physical address. So how we have to convert from logical address to physical address we will study here. So it is being done with the help of relocation register. Okay. So let me change the pointer option. Okay. So let's say as we had discussed in the previous video, we are going to the party. Okay. And the party contains 100 people already. Okay. And 4 family persons, our family persons are going to the party. Okay, so our logical address for the first person will be the 1. Okay, for the second person it will be 2, and same way the third person will get the third logical address 3, and fourth one will be getting 4. After entering into the party function, we will get to know about that first person which is entering the party will be the 101 person or 101th person of the party. Okay, so this basically is the concept of physical address and logical address. The person for which we are referring to our family locally, then we are getting the logical address. After entering the function, we are getting physical address. So here as you can see that the relocation register is 14,000. Okay, so let's say there is memory like this is 0 and relocation register is now 14,000. Okay, after entering of 346 address, so we will simply add this 346 to the 14,000 and now we are getting this 346. Okay, so this will be the physical address. So as you can see that this will be the 14,346 address which we are getting as physical address in comparison to the logical address which was just 346. So here our contents will be stored, or we can access our contents from this 14,346. Okay, so runtime mapping from virtual to physical address is known as memory management unit. Okay, so this is the memory management unit. Now talking about dynamic loading. So what is dynamic loading? Firstly, we have to learn about what is the need of dynamic loading, what is dynamic loading. So as you can see that in previous functionalities, if we load all the resources which a process needs or process is requesting in its lifetime, if we are allocating all the resources at the same time, it will not be that efficient, because at all time CPU or any process will not need all the resources. Okay, these resources at the same time can be utilized by other processes also. So firstly we have to make sure that all the processes, when computer needs or when any process needs, they should be made available. Okay, this is not necessary that all the processes are means present at the initiation of the process. Okay, if a process is initiated, then it is not necessary to keep all the resources at the initiation. We can get the resources at the time of execution, means at the time of runtime. If a process needs any resources at tth time, then at tth time it will request the memory, and from there it will get the resources at t time. This is known as dynamic loading. Okay, and what do we mean by dynamic linking is that if the computer system or any process is wanting any resources, it need not to have all the resources at the same time, means at the time of initiation. Then it will just add the stub part to the libraries. Okay, so let's say this is the library earlier this was the library. It will add one stub. Okay, it will add one stub. What is the stub? Is that is included for each library routine reference. Okay, so there is a reference to the library which is being made. Okay, so when we will call this library, then we will execute this stub. Okay, from this stub we will get to know that there is a reference here in the main memory. From there we will get the resources at the time of execution, and this is known as dynamic linking. Okay, so this feature can be extended to library updates. Okay, so if there are updates in any library, so this was the earlier version of library, if this was the update, okay, so here we will directly give a stub, a reference which we will add to this library, and will give the reference to this update. Okay, so this is the main methodology of dynamic linking. Now talking about swapping. So what do we mean by swapping is that, as we had discussed in earlier slides, as we know that if we don't need any process, then we can store it in any backing store, and the higher priority process, okay, so if the higher priority process is requesting the attention, we can directly fetch that process from the backing store and can continue to execute. So what basically I'm saying is that, let's say there are two processes. Okay, so one is having higher priority and one is having lower priority. Okay, so this and currently this the CPU is executing this process, okay, the lower priority process, and it is getting the attention or interruption of this higher priority process. So what it will do, it will store the information, all the already executed resources, to the backing store. Okay, here it will store it in backing store, and it will take the control of the higher priority process from the backing store, and it will come into main memory. Okay, so there is the backing store. As you can see that backing store is very large, we can call it as secondary memory storage. So as you can see, the first function is swap out, means the lower priority process is going to the backing store, and the higher priority process is coming, means swapping in to the main memory from the backing store. So this is known as roll out, roll in. Okay, after backing store is commonly a fast disk. Okay, so it is commonly a fast disk, means the transferring is done very fast, and it must be large enough. Okay, to store all the processes we need a large amount of memory, and we already also have to store many copies, several copies we have to store to provide direct access to it. Okay, and as many users are accessing, we need many copies, and thus we need a large amount of memory. So the backing store will be large comparably to the main memory. Okay, now in next video we will be talking about contiguous memory allocation. So till then, thank you. And one more thing, if you need these slides, then you can access it from the last video of this module. Okay, so probably it will be done by this week, then you can get the slides from this last video of the slide. Okay, till then, thank you.